All right, let's get started, I guess. Thank you for showing up in such large numbers. There's a lot of competition. If at any point you feel like this is not for you or this is not interesting, Denise Cavalieri has absolutely brilliant session. I'd be there if I didn't have to be here, but well, that's the way it is, I guess. So, let's get started. Quickly, about myself, I'm Everett. That's my mug right there. I'm a freelance network engineer. Been into this for the last 12 years or so. It's probably getting to the point where I should remove the network and replace it by infrastructure, because the last few years I've mostly been focused on data center and more specifically NSX and AVI as well. In my free time, I like long walks on the beach and the sound of summer rain, but that's not why we're here. We're not here to talk about myself. We're here to talk about AVI. Quick recap on the architecture of AVI. ALB, whatever VMware has decided to call it this week. In case you don't know, in case you need a refresher, AVI has a construction of a controller, which is essentially your management in your control plane. This is where you'll do all your configuration, all your monitoring, that whole stuff. And it has service engines right here, which functions as your data plane. If you're familiar with checkpoint firewalling, this is like their smart dashboard. If you're familiar with F5, your controllers essentially function as big IQ. There is a big difference there in that your controllers, so your service engines themselves, have no configuration capability. They're just a dumb box that load balances traffic based on configuration that has been sent from the controller. Important terminology and configuration differences. If you're coming from F5, there's a few differences in the way these are set up. These boxes, they're largely similar in constructions, but there's some changes. What F5 calls a virtual server is called a virtual service on my AVI. It's easy enough. What AVI calls a VSVIP, your actual IP address, is part of your virtual server on F5. They don't really split that out the way AVI does it. What F5, on the other hand, does on separate HTTP policies, which is where you'll configure your request policies, stuff like that. This is part of your virtual service config on AVI. Nodes are part of pool config on AVI as well. There's no separate node construction. And the important one, what F5 does with iRules and Tickle is something that AVI does in Datascripts, but they're written in Lua instead of Tickle, which is an involved migration process. On to the important stuff. Actual things that we have picked up in our migration from F5 to AVI. Number one, the UI. Way back in 2016, I was talking to AVI at Cisco Live before they were part of VMware, and I asked them, what do you guys do that F5 or Citrix don't do? And the answer was, not much, feature-wise. Fast forward a few years, and it hasn't really changed. However, what is important is that the feature set or feature parity is there, but AVI has an absolutely brilliant UI. And that is the one thing I will always fault F5 for. The UI is functional, but you can't use it for proper troubleshooting, in my experience at least. I have a few examples of that. If you've ever needed to do in-depth troubleshooting, packet captures are brilliant. Packets never lie. What's there is there. AVI has that built in right in the UI. You select a virtual service, you select any sort of filter you might want, you select if you want a certain amount of packets or if you want to capture it based on time, and you just have it go. Very useful. This will also capture all traffic. Traffic going towards your virtual service on your service engine, but also traffic leaving towards the backend pool. So you're not limited to one direction or one interface. You're capturing everything related to that virtual service. Also very useful. By default, it will not capture your health monitor. Generally, if you're troubleshooting something, you don't really care about traffic from your health monitors. That's just there. You know that works, because otherwise your virtual service would be down. It's excluded by default. You can include it if need be, in case your health monitor are failing for some unknown reason. And finally, also very useful, the packet captures allow you to capture your TLS session keys. So you can capture your traffic, import it into Wireshark, select the session key, and you can look into encrypted traffic for any sort of in-depth troubleshooting there. A few other very useful things. By default, the load balancer will only log what it considers significant traffic. I'll get back to that later. You can enable non-significant logging in case you're trying to validate that everything is working. the way you want it to, because the load balancer might say it's all fine, your application itself might be broken, and it can be useful to capture non-significant traffic. You generally do this on a very specific timing, because this does increase load on your service engines tremendously. There's just a whole bunch of traffic that you're suddenly capturing and logging that you might otherwise just discard immediately. So there is a timer for that. Small annoyance, you do need write access to a virtual service to even enable significant logging. This can cause some trouble depending on your policies and the organization you work at. Also very useful, which is what you see right here, is latency metrics. By default, every virtual service will have a bunch of latency metrics. Now, I don't know about you guys. I'm assuming everyone here is in infrastructure, but I tend to have occasional discussions with application owners on why stuff does not work. Rarely happens. It's never our fault, of course. It never is. It's always the network. But every now and then, you get into these discussions. And in the past, I've always had some difficulty trying to figure out where does this come from? Where is your issue? Why is your application slow? The graphs for AVI, for the load balancer, show it immediately, up to a degree, of course. Based on the amount of logging you've selected, for that specific time frame, the load balancer will tell you the latency, the average latency between the clients and the load balancer itself, between your service engines. It will calculate the latency between your service engine and your backend server. But more importantly, it will calculate how long it took an application server to actually send the reply back to the load balancer. So the next time someone goes, hey man, your infrastructure is terrible, it's slow, it's not my application, you can point to that graph and go, I'm sorry, this is 150, let's ignore that for a second. This took ages. I can't control how long it takes your API to answer. You might have an infrastructure problem, maybe your database is having issues, but it's probably not my network, it's probably not my infrastructure. And finally, probably the biggest one for us at least, has been log analysis. Anything that does get logged in the load balancer will give you a bunch of information. You'll see the same latency metrics that you see for the virtual service, but you'll see it for that individual log. You'll also see a location. This is largely what you define yourself. We have defined this source IP address as something that's coming from our own data center, but this could also be your public cloud. This could be whatever you have defined your subnets as being. You'll see a bunch of stuff that the load balancer is trying to get from user agents, essentially. This can be your operating system, the devices, and very important, you'll see information on TLS. Again, if, like me, you're dealing with legacy applications every now and then, you might run into issues where applications don't necessarily like the TLS settings that you're forcing on them. This is one great way to figure out what's going wrong there. You'll see both your version, but also your encryption algorithms, whether or not you're using PFS, and any sort of SNI statistics. What you'll also see is the entire path that your application has taken. I'd love to show you more. I had to black it out because this was an internal log for ours. But you'll see the IP address that is actually being used on the front end. You'll see the backend IP address of the service engine that is handling your connection. And you'll see the backend server that your traffic is being sent to. And finally, the most important things here. If this is a significant log, which it probably is if you're looking at it, you will see why that log is significant. In this case, you'll see a high round trip time to my server. That's not OK. This might also be, well, this is an HTTP code that I did not expect. This is a 401. This is a 404. This is a 501. This is not OK. I know this is not the way my application is supposed to behave. And finally, if you have configured your virtual server to log all headers for logs, and you should, it's very convenient, you get to see all headers that your client has sent to your load balancer, that your load balancer has sent to the backend, and the other way around, what your backend has sent back to the load balancer and how your load balancer may have manipulated that traffic on the way back to the client. This is very useful for troubleshooting persistency issues, for example. The second lesson we have learned, tweak your analytics profiles. Now, quickly, if you don't know what analytics profiles are, all virtual services have an analytics profile. And it is primarily used to define what is a significant log and how healthy is your virtual service or your pool. Now you might say, why do I want to tweak this? Well, you don't want false alerts. You don't want to open that console and see a bunch of virtual services that say, oh, it's got terrible health. There's a bunch of things going wrong when it's all just going fine and your profile just hasn't been configured for it. So very importantly, know the application that you're load balancing, or know the owner of the application you're load balancing and talk to them and figure out how you can tweak those profiles to be as efficient as is possible. The two main examples here are your HTTP codes. By default, there'll be a few codes in there that'll be excluded. We have on our profiles excluded 401 codes, for example, because we have a bunch of applications that run NTLM and Kerberos, and every other request is going to be a 401 because it's not yet authenticated. We don't care about that. This is expected behavior. We have excluded that. Similarly, latency, you'll have default settings for what is an acceptable latency for an application before it starts just degrading. We have applications where that API is very slow. It does do a bunch of backend requests that take ages to get back to the client. The client knows this. This is absolutely fine. We have increased the latency thresholds for that. Why? Because we don't want to see bad health on our virtual services if they're just working as expected. Lesson number 3, I am rattling this off. If you do have questions, feel free to interrupt me. It's automation. AVI is huge with automation. Anything you do in the UI is translated to an API call on the backend. This is not my words. This is the BU's words. That also means that anything that you want to do, you can craft an API call to do that. However, with a very complete API, usually comes a very complex API. There is a lot of stuff in there. There are a lot of parameters. AVI supports any public cloud you can think of usually. It supports a bunch of hypervisors for its clouds, and all these clouds have different settings, different requirements. What you want to push to Azure, you probably don't want to push to GCP or to your on-prem clouds, for example. But all those settings are, of course, in the API. So what is very convenient there is your controller has a Swagger page. If you browse to, well, the FQDN of your controller /Swagger, you get to browse the entire API right there in front of you. It has all the objects that are configurable, and it has all the parameters. It's just a full open API spec. And very importantly, you can try it out. That is to say, you can try out any GET call. If you want to do posts, you run into CSRF token stuff. It becomes a bit more complicated. You could technically do it. It's a bit more difficult. But this is very useful for grabbing the API definition of your service if you want to implement that somewhere else, for example. If you're interested in that, shameless self-plug, I have written some blog posts on how we have automated our deployments with Terraform, for example. So next up, a bit of information on HTTP policies and Datascripts. Probably importantly, why would you use these things? 90% of your traffic can probably just pass through your load balancer without much else. It comes in, gets load balanced to a backend, you're good to go, carry on. However, every now and then you might want to do some manipulation. You might have some headers that you want to add. You might have some specific headers that you want to remove. You might want to filter incoming traffic because you might not want to allow all IP addresses to access that traffic. You can do that with policies or data scripts. HTTP policies, they're really easy to understand. You go to edit your virtual service, you go to policies, and it's right there. You see the request policy, and you add rules just like you would for a firewall, for example. Starts at the top, looks at the requirements, looks at what it has to do, continues until it gets to the bottom. Very easy. Really annoying to scale manually. Every rule you want to add, you click in the UI, add the rule, or you add it in your API, you add the rule. And again, importantly, you need write access on your virtual services to see this policy, because this policy is part of your virtual service configuration. If you don't have access to configure a virtual service, you don't have access to the policies in that virtual service. On the other hand, you also have data scripts. Data scripts are what you do on F5 with iRules. They're harder to read because you're reading code at that point. It's not a simple UI. You're looking at actual code, and you need to understand the Lua code that's in front of you. Not necessarily hard, but it is a bit harder. It is easier to scale, although, small downside, anything that you want to refer to in your Datascript must be configured to be used. One example would be if you have a Datascript that defines where traffic has to go based on an FQDN. Any pool you want to direct to, you have to add that in your Datascript initially and say, I want these pools, add. Also makes it a bit difficult to scale. On the upside, this is fine with read-only access. Datascripts have their own separate tab that everyone with read access to that section, of course, can see. Another major advantage here is they're very flexible. We use a Datascript to host our proxy pack files, for example. We have a source list of subnets that still need to use an explicit proxy for several reasons. Based on that source IP, we will hand out a different pack file to the client that is requesting it. Most clients just have a direct line. Other clients have a very long pack file defining what is direct, what is going to an explicit proxy. But you can go very far in this. If you have an application where you say, I only want people to access this the third day after a full moon, absolutely possible, right there. Do you need that? Hopefully not, but you might, and the possibility is right there. Now, instead of using policies or Datascripts for your redirection, you could be using virtual hosting. This is something that was also very big for us. Now, virtual hosting, really easy on a high level. You have a parent virtual service. It's where you define your TCP and your UDP settings. It's where you link your actual IP address. It's where you link your SSL profiles, if relevant, and your certificates. And then you have a bunch of children underneath that. Why is this useful? Well, every child has its own pool. And every child has dedicated settings for your application, for your web application firewall, and for your analytics. This can be useful. Why? You might have an application, for example, that runs on one FQDN, right? You have your root virtual service right there. And some applications that are running on that FQDN, they might need NTLM. Right. You use that analytics profile that is configured for NTLM. Something else might run an entirely different application. Maybe that's important and you want a WAF there. You can put that WAF in front of it, but only for that application. And again, this gives you visibility. You don't need to dive into Datascript code. You don't need to dive into policies. It's all right there. Virtual hosting comes in two flavors. There's SNI, which you probably have heard of. I hope you have heard of if you're doing any sort of security things, part of the TLS specification. It's also a type of virtual hosting, where your virtual hosting will be based exclusively on SNI. What does this mean in AVI? You can only do your redirection based on HTTPS. It's a bit of a downside, although a small one. You can only match traffic on FQDNs as well. All connections are handled by the parent. This is not really impactful, but useful to know. And you can only link one RSA and one EC certificate. And that is a big limitation of SNI. You're basically forced into one domain or one certificate that has all those services. Enhanced virtual hosting, on the other hand, is newer. It allows so if we're recording that, enhanced virtual hosting does both HTTP and HTTPS, but it also allows you to match on a path. So you're not limited to only redirecting traffic based on FQDN. You can redirect it based on the path. Your connections are going to be handled by the children here, and you can add as many certificates to this profile as you want. So if you have 7 different domains, you can have 7 different certificates. Generally, even your sounds will be limited to a single domain. If you're doing it like this, you can have actual different root domains here as well. Quickly going to pause, maybe quickly fix the microphone. All right. Working again. Thank you very much. So I'm quickly going to recap this for Garrett's recording. SNI matches HTTPS only, matches on FQDN only, connections are handled by the parent, one certificate, one domain. EVH matches HTTP as well as HTTPS, can match on path, so you can send traffic to with the same FQDN but a different path to different pools. Connection is handled by the virtual service child and has as many certificates as you want. If you want 10 domains behind a single IP address, absolutely possible. Now, a big one for us was NSX integration. We are in the process of deploying NSX. If you aren't, you should. It's the bee's knees. It's really cool. I'm a massive nerd for networking. I love it. Now, why would you want to integrate with NSX? The big one, security groups. Again, we're hosting infrastructure for developers usually, for people to host applications on. Every now and then, those applications are going to be scaled up or scaled down. Servers are going to be added and removed. I don't always know about this, and I probably don't always want to know about that, because I've got stuff to do that is more important. I'll be a bit more static, maybe. So what you can do when you integrate NSX is you can leverage your security groups. And if you've defined your security groups in NSX properly, to the point where they are updated automatically, all right, let's use this then. So if you have set up your security groups properly, meaning they are dynamic, they're based on tags, for example, or based on host names if you have to go that way, that means if you're using that security group as your backend for your virtual service, it is updated automatically. Someone spins up a new web server. It's Black Friday. Oh shit, the web shop is getting 5 times the amount of traffic we're expecting in the normal days. No worries. People have spun up those web servers. They did a great job. They automated their VM deployments. They automated the tagging of their VMs. Brilliant. All those VMs are added to your security group in NSX. Your firewall policy is instantly okay, but your load balancer is as well. If later on those VMs are then decommissioned, because we do private cloud, we spin things down if we don't use them, they're removed from the backend as well. You're not sending traffic to something that doesn't exist. You're not getting alerts for servers that are down because they no longer exist. You're just linking to a security group, which is updated automatically. A bit more on the integration. There are some limitations. Your controller will create groups for your service engines and your virtual services. Great. You don't have to manage that. Your service engines are dynamic. You don't want to deal with that. Your virtual services might be dynamic. You don't want to deal with that. However, what it does not do is synchronize VS-VIPs. Any IP address you add on AVI does not get automatically added to NSX. If you were hoping you could get away with IP-less groups in NSX, it's very unfortunate. I've asked the people, when we met them, they said, nope, this is a conscious decision, we're not doing it. They had a great explanation for it. If I weren't a goldfish, I could tell you, but I've forgotten what it was. I did agree, or I did understand why they didn't do it. Also importantly, when you're linking in NSX Cloud, you're limited to linking one segment to one tier 1 gateway. You can have multiple tier 1 gateways in your cloud, but every tier 1 gateway can only ever have one segment where you'll source your VS-VIPs. Why does this matter? Well, you might have multiple environments. You might have multiple tenants. You might want one tier 1 with multiple segments. How do you deal with that? Well, you could do what we did. We just added 4 different clouds with the exact same NSX manager cluster. Nothing stops you from doing that. The reason we did that, we have one tier 1 gateway per tenant. Every tier 1 gateway has 4 environments, dev, test, UAT, production. This allows us to have 4 segments for that tier 1. What you could also do is have a dedicated tier 1 gateway where you source all your traffic from, where all your VSFIPs from, if your environment is small enough, or if you have enough licenses to where you're just spinning up tier 1s for every environment available. Or you can share your service engines in a way like this. What do I mean by that? Because I just realized how confusing that must sound if you haven't set it up. You can have up to 9 VNICs on a service engine. So combining your multiple NSX managers, your multiple clouds, means that you can have multiple segments on that cloud, which means you can have up to 9 environments on a single service engine. It is a hard limitation. You cannot have more than 9 service engines or more than 9 VNICs on a service engine, so you are limited to 9 segments on that single engine. We're almost there. So a little bit of information on maintenance. Again, talk to your application owners or know your applications. In your health monitors, you can define maintenance codes. This is useful. If you talk to your application owners or to developers of your application, you can agree with them on certain patterns, either HTTP codes or HTTP data responses, that will put a backend server into maintenance. This means those people don't have to go into your load balancer and disable a server for maintenance or updates. They can just send a 503. The load balancer gets a 503 from the server. It knows the server is in maintenance. Remove it. Don't send new traffic to it. Have it die down. Server is now gone. Good. Server starts replying normally again. Add it to the pool. As said, you can do this with response codes. You can also do this with response data. So your server can just send a 200 with a specific string of data in there. It just says server maintenance. Load balancer will just remove it from the pool, no longer send traffic to it, and allow you to do that maintenance without impact on it, without waiting for your health monitors to go down, essentially. And finally, role-based access control. Everyone loves this, right? We have a requirement where we want to let some of our developers, some of our application owners look into our load balancer. They do a bunch of maintenance themselves. We haven't gotten around to doing the maintenance codes, do as I say, not as I do, but we have gotten around to giving them specific access to the load balancer if they want to bring their own nodes down. Now, I don't want to give just about everyone read access or write access to something that is as sensitive or is as important as our load balancers. So how do you deal with that? You use tags. Just about every object in AVI has the option to add RBAC tags to it. It's just a simple key value system. You've all seen it before. You can then use those tags and add them to a role. You might define that role to have write access to pools, so people can add and remove servers, but only have read access to virtual services, for example, or only have read access to VSFIPs. So they can see their entire infrastructure, and they can manage their own pools. But they don't get to see anyone else's infrastructure. They don't get to accidentally click the wrong pool and delete 7 servers, and then everyone is mad at you because your load balancer failed again. RBAC does that for you, and it uses a simple system with tags and markers. Very important limitations. Some things here are visible always. You do need to give read access to a bunch of stuff by default if you want to give read access to anything at all. For us, this means everyone gets to see our packet captures. That is not ideal for obvious reasons. Make sure people do clean up their packet capture stores. You don't leave those hanging around. And also, very importantly, there is a parameter called allowed unlabeled access. By default, this is set to true, and it does exactly what it says on the tin. You have access. If a resource is not labeled, which in our case is most of our resources, everyone with that access gets to see it. You want to give write access to certain pools to someone. If this is set to true, you've given them write access to all pools. Not always ideal. Also, not available in the UI for some reason. So this is something you do have to go through the API or the CLI to disable it. And finally, if you are interested in legacy stuff, every now and then you might have to deal with NTLM still. Everybody loves NTLM. It's been around forever, refuses to die down. I feel it's a bit like the faxing of authentication protocols. If you do need to do NTLM, Read the docs. There's a lot of them. Read them. It'll help you. There is an application profile setting that will help. If you know how NTLM works, you know it authenticates a connection. If you know AVI, you know it'll do connection multiplexing by default. That doesn't really mesh very well with NTLM. The nice people at AVI and VMware have thought about that. There is a lovely setting right there, detect NTLM. AVI will look at your headers, will detect that it is in fact NTLM, and will deal with it accordingly. It will basically disable multiplexing for those connections. Now, if you are in a very weird environment, not saying I am, I just heard this from a friend, that might not be enough. You might run into issues still, because it's not only a legacy application, it's a legacy client, and it's all a nightmare. That's when you have this. You disable keep alive post, a very specific setting for Internet Explorer 6, because of course it is, and everything magically starts working. Once you've done that, it's all working. Again, referring to earlier, you update your analytics profile, and you remove those 401s from your unhealthy traffic. Because again, you don't want to deal with that stuff. And yeah, that was about it for me. If you have any questions, feel free to ask them now. If you don't have any questions, good. I either did a great job or a terrible job. I don't bite. I'm here all day. If you have questions later on, feel free to talk to me as well. Feel free to reach me on my socials. The presentation will be out there. My information will be in there as well. And once you're done, please take the session surveys. I'm sure everyone says this. I'd love to know if I did well. I'd also love to know if I was absolutely terrible and you'd like to never see me again. Very useful information for me. But that's all I have for you. Thank you.